Good day. For today's lecture, we will be studying about the mechanics of impact and how to analyze when two objects collide together. Okay? So, impact occurs when two bodies collide with each other during a very short period of time in which there's a large impulsive forces that is exerted between the bodies. So, one of the examples are when you strike a hammer on a nail, or when you strike a golf club on a golf ball. So these are examples of impact loadings. So basically, there are two types of impact. We have central impact and oblique impact. Now, central impact occurs when the direction of the velocity or the motion of the particles is along a line passing through the mass centers of the particles. So this line is what you call the line of impact. So this is the line of impact wherein it connects the center of the two masses horizontally, and perpendicular sa imong line of impact is the plane of contact. Now, when the bodies, the motion of ganing duha ka particles nimo is aligned sa imong line of impact, so the type of impact is what you call central impact. Now, in contrast, when one of these objects is at an angle sa imong line of impact, that is what you call oblique impact. So, pwede nga ang both particles, ang ilang motion is naka-angle sa imong line of impact, or pwede po one of these particles isa lang, no? At an angle sa imong line of impact. Ang resulting impact is oblique. Okay, so how do we analyze the impact? First, nakiduha ka particles A and B, impact will only occur when, sample kani, when the velocity of the object A initially is greater than B. Okay, no? Siyempre, kung kusog ang B, dili na madakpan sa imo ang B or di na mabanggaan. So, mo requirement niya, no? Dapat kusog ang ang A. Velocity niya compare sa B. Now, ang B, pwede po na siya atras. Samot, no? Kung atras siya, so banggaan siya sa A. Okay, so this is before the impact. Now, during impact, during the collision, sa'yo may tabo. We can assume na kaning imong particles as deformable or non-rigid bodies, di ba? So, kaning nga scenario, we will assume nga mo deform ang ang object. So, the particle will undergo a period of deformation. And they exert an equal but opposite deformation impulse on each other. Okay, so pagbanggaan nila, most likely deform na sila, causing a deformation impulse, no? Na sila mag-exert sila og impulse with each other, no? Equal and opposite. Now, when umaabot na nila ang point of maximum deformation, what will happen? So, during maximum deformation, there is a period wherein mo travel sila og at the same velocity. So, mo na siya at maximum deformation. And then, after that one, they will experience a period of restoration in which the particles will either return to their original shape or remain permanently deformed. So, kung elastic ang imong object, so mo balik na siya somehow sa imong ang original shape. The equal but opposite restitution impulse pushes the particles apart from one another. No? So, napo sila exert pa sila og restitution na impulse, no? With each other. However, in reality, the physical properties of any two bodies are such that sa reality, always greater ang deformation impulse sa restitution impulse. And then, so kung mo-try man na sila og restore sa ilang original shape, so ang ending mabulag silang duha. So muna din ni after impact, the velocity of B will now be greater than the final velocity of A. So mo ni siya ang mechanics sa imong impact. So how do we reflect this sa atong equation? So in most problems, given ang imo ang initial velocity, no, given yung duha usually. So imo na lang pangitawon is kaning duha ka unknown, the final velocities. So ang imong buhaton ana is, in this regard, momentum for the system of particles is conserved during collision. No, the internal impulses of deformation and restitution cancel. No, so hence, referring to figure 14a, ani, and A and E, so we can apply conservation of momentum, no, okay, di ba? Cancel out naman ang kanilang mga impulses, no? Cancel out naman. So we can apply the conservation of momentum. So muna rin, MA VA1 plus MB velocity V1 is just equal to MA VA2 plus mass of B times velocity, final velocity of B. Okay, so you now have one equation. So kinahanglan tag another equation. So in order to obtain a second equation to solve for VA2 and velocity V2, we'll apply the principle of impulse and momentum. So aha na to i-apply. So i-apply na to diri nga phase, diri diri from point 1 and then dinhi. Okay? I-apply na to ang principle of linear impulse and momentum. You have MA for, remember, for particle A only, MA VE1 initial velocity, initial momentum minus PD. Tinganong minus man because kani mo man na felt sa imo ang A during aning deformation impulse is just equal to MAV. Okay, and then also for the restitution phase, ang restitution phase is starting diri, taman diri. Okay, so you have MAV minus RDT is just equal to MAV2. And then kung imo ning i-divide ang restitution impulse by the deformation impulse, you will get this expression. E is just equal to V minus VA2 over VA1 minus V. And then this is for particle A. We will also apply the principle of linear impulse and momentum for particle B. So in the same way, makuha na to ana is kani E is just equal to VV2 minus V over V minus velocity V1. Okay? Now, ang atong target man is ang kani VA2 and velocity V2. So we need to eliminate kanang V. So ang pag-eliminate ana is imo ra ning i-add ning numerator. I-add po nimo ang corresponding denominator and you will get this one. You will get this one, no? Yan ang i-add man nimo kay the same man siya o quotient kani. Again, tricks ra na sa kuan sa mathematics algebra. Okay, so this is now your second equation. This is your first equation. This is your second equation. Okay, unsa may pasabot aning coefficient of restitution? Ang pasabot ana niya, ang value ana niya is from 0 to 1. Meaning, kung 1 ang value ana, perfectly elastic siya. So, pagbangga niya na, mubalik dito sa siyang original na velocity or original na shape, no? So, although in reality, no, the deformation impulse is equal and opposite sa imong restitution impulse. Sabot anang A equals 1. In reality, this can never be achieved, no? Di mahitabok, no? Kaya naamang kay losses, ana. Na may energy nga mawala, ana. Pagbangga, ana, there is sound. So, katong nga energy sa pagproduce og sound, makakuha na to siya. Loss of energy na to. Now, when E equals 0, that is called plastic impact. So, plastic impact meaning 0 ang imong restitution, ana. So, wala na restore. Ang object is ni stick ra gyapon, no? Ni stick ra siya, uban ra siya sa diri ra sa taman sa diri ra sa taman, diri nga face ana, diri. Wala siya na restore. When A equals 0. Okay, so we will have example. This one, you have the bag A having a weight of 6 pounds is released from rest at the position theta is equal to 0 degrees. After falling from 90 degrees, it strikes an 18-pound box B. This is one. The coefficient of restitution between the bag and the box is 0.5. Determine the velocities of the bag and box just after impact. What is the loss of energy during collision? Okay, so you have object A, object B. You have the coefficient of restitution. And also, makuha nimo ang initial velocity, ana. So, ang impact happens when pag-abot sa A diri. So, diri ta mag-start sa itong analysis. Okay? Okay, so let's have this example. You have a bag A having a weight of 6 pounds is released from rest at 0 degrees. After falling to 90 degrees, it strikes an 18-pound box B. If the coefficient of restitution between the bag and box is 0.5, determine the velocity of the bag and box just after the impact. And also, what is the loss of energy during collision? So, you're asked to find velocity A2 and velocity V2, and also the loss of kinetic energy. Okay, so we will apply the conservation of momentum for this central impact. Okay, so this is an example of central impact because the mass and the velocity, the line of impact and the velocity of the objects are aligned. Okay, so applying the conservation of momentum along X, you have, by the way, for this scenario, pwede tang going to the right positive or pwede po going to the left positive lang. Pwede gapon na. So you have MA VA1 plus MV velocity V1 is just equal to MA VA2 plus MB velocity V2. Okay? Okay, so for velocity V1, since at rest man so therefore 0 na siya. Okay? And then, ang imo ang velocity A1, by the way, kanina na itong doang pakitan. Ang velocity A1, makuha nimo by applying conservation of energy. Okay? So you have applying conservation of energy. If this is your datum kanidere, you have you have 0, kinetic energy plus potential energy at point 1 is 0. Or in other words, T1 plus B1, this is your point 1, this is your point 2 somewhere here. Kinetic energy, 0. Potential energy, 0. Therefore, this dito, this is just 1/2 ma velocity squared, or 1/2 ma velocity a1 squared plus potential energy negative mgh ma g times ang h na to is 3 feet. Okay, so cancel na ning ma. So you have velocity a1 is just equal to square root of 2g h, or 3 feet. You have g for English system is 32.2 feet. Yan, ay isa ka feet, so may mga feet square over s square times 3, or VE1 is just, ilan na siya? 64.4 times 3, 13.9 feet per second. Okay? Ang direction is going to the left. Okay, so kaning any mo is going to the left. Okay, so ato na din yung i-plug in diri. I will now erase this one. A1 13.9. May tabuan ni, you have MA is 6 pound times 13.9 is equal to 6 VA2 plus, by the way, assume nato no nga ang VA2 is going to the left, velocity V2 is going to the left also. Assume nato nga after ani, B will be going to the left and ang A ni mo also going to the left. So positive rin eh. Plus 18 velocity V2. Divide natin ni by 6. You have you have 13.9 VA2 plus 3 velocity V2. The other equation, makuha na to by using the coefficient of restitution na equation, which is velocity V2 minus velocity A2 over VA1 minus velocity V1. So you have 0.5. Again, this one is, connotation is positive going to the left. So you have velocity V2 minus VA2 over, 0 naman eh. VA1 is 13.9 going to the left, so 13.9. Okay? So ang atong ikaduhang equation is velocity V2 minus VA2 is equal to 13.9 times 0.5, 6.95. 6.95. Okay? Okay. So we now have two equations. So this is equation 1, equation 2, two equations, two unknowns. So using your calculator, you will get this one. VA2 is equal to negative 1.74 feet per second, and velocity V2 is 5.21. Okay, 5.21. So sa pasabutan ni since positive ni meaning ani going to the left ni sa based sa convention. And then kani negative pasabutan ni this is just 1.74 feet per second going to the right. So kani di ay after sa pag-collide nilang duha na balik ang A going to the right. Okay? So that's it. Now, for the next question, what is the loss of energy? The loss of energy, makuha na ni sa nimo by applying the loss of energy. So, kuhaan nimo ang kinetic energy. Loss of kinetic energy. So, question is, what is the kinetic energy at point 1? So, 1 half MAVA1 squared plus 1 half MB velocity B1 squared minus no 1 half MAVA 2 squared. Mali din eh. Final minus initial din eh. Final minus initial. Okay. So, pila ang final kinetic energy minus sa initial kinetic energy? This is just kani ang 0. Kani ang 0. So, you have 1 half times convert na to ni para pound na nga to ang by the way, unya ra. MA is pound mass man eh. So, 6 pound mass VA 1.74 squared. Right? 1.74 squared. Plus, ang unit ani, by the way, ang unit ani feet square per S square. Okay, so ang unit ani din nila is pound mass feet square per S square. So ako na lang kung ano ning unit ani. There. So may maning 6 times 1.74 squared plus 18 velocity V. Velocity V is 5.21 squared. Tama. Minus 1 half 6 velocity of A is 13.9. 13.9 squared. 0 man na. So, unit ani nila tanan is pound mass feet square per square. Later on, ato na lang i-convert para may mong put pound. Okay, so the loss of kinetic energy is just kani ito running subtract. Okay, so you have 6 times 1.74 plus 18. Okay, so pag multiply ni mo ani, ang result will be negative 326.5 0.2503 pound mass feet square per second squared. Now we need to make the unit into foot pound. Unit of energy man sa English system. Foot pound force to siya. So we need to 1 pound force is 32.2 pound mass feet per second squared. So cancel lang isa. Cancel na ni. Mabili na lang ang foot pound. So ang answer ani would be negative 10.1 foot pound. Ano nga pound force? Okay? So this is the loss of kinetic energy. Muna nawala ang kinetic energy. So later on we will solve for oblique impact. Discuss the other type of impact, which is the oblique impact, wherein the direction of the two particles is at an angle at the line of impact. Okay? So, pwedeng isa lang ang naka-angle sa line of impact, ang isa is aligned sa line of impact, or pwede dua. Okay? So, how do we analyze oblique impact? So, first is you resolve the velocities in its x and y components. So we resolve the momentum of the particles, MAVEX1, MABEA1, and also for the particle B. And then usually you have unknowns, you have four unknowns, VAX, the final velocity, and the angle. This one, P sub 2 and P sub 1. Okay, so after you have resolved the momentum in its x and y components, you assume the direction for the final velocity of the A and B. Pwede mo na siyang i-assume. Usually, you assume this one in the positive direction. And then, you apply this equation for the coefficient of restitution, because the impact occurs only at the line of impact, or for this case imong x-axis. For the y-axis, momentum of particle A and B is conserved at the plane of contact. Kaya wala may impulse nga, wala may forces along y dire, or there's no force along y. So momentum is conserved. Therefore, MAVAY1 is equal to MAVAY2, or the velocity at the y component is just equal to the velocity at the final component in the y direction. Okay, so in order to illustrate this one, let's have this example wherein you have two small discs A and B. This is A, this is B. The mass of A is 1 kilogram and for B is 2 kilograms respectively. Now they collide with the velocities shown. If the coefficient of restitution for the disc is 0.75, determine the x and y components of the final velocity of each disc just after collision. So we are asked to find the final velocity in the x and y direction for these two discs. Okay, so let's take this example. Okay, so let's take this example. You have two smooth discs, okay, A and B. Now the mass of A is 1 kilogram, the mass of B is 2 kilograms. Now these are the initial velocity for A and B and the angle with the line of impact. So we are asked to find the final velocity of A and B. Now, ang coefficient of restitution is 0.75. Okay? So how do we analyze this one? First, let us resolve the components of A and B, the initial velocity along x and y. Okay, so you have VAX1. VAX1 is, by the way, if we draw the impulse and momentum diagram for A and B, it will look like this. This is A. This is your initial momentum along x, along y, plus sa may mabatian aning A, naa siya yung mabatian nga negative impulse, right? Gi-exert sa B. Okay, this will result to, wala ta kabalo kung aha padulong ng A, so we will assume nga positive poro. Okay, going dire MA VAX DAX2 and upward MAVAY2. For mass B, again, for B going downward, MV velocity V Y1. Going to the left also, MV velocity BX1 plus sa mabatian sa B, sa B na igatulod sa yaa. No? Na igatulod sa yaa. Patamuatan na ni dari ni. Na ay impulse B. Again, we will assume positive. Kung natin makuha later on yung negative, pasabutan na opposite sa itong i-assume. This is MB velocity V X2 MV velocity V Y2. Okay? Okay, so velocity AX1 is 3 cosine 30, which is 2.598. Unit ani is meter per second. Velocity AY1. So this is 3 sine 30 or 1.5 meter per second. Okay, so you have velocity Vx1. Velocity Vx1 going to the left, no? So negative negative cosine or sine, no? Pahira, negative cosine 45 degrees. Okay, 1 naman na siya. So this is negative 0.7071 amperes. Velocity By1, again pa downward, negative ako ni, negative sine 45, negative 0.7071. Okay? Since na-resolve na nato siya, we'll now apply the conservation of momentum along x. Okay? So, conservation of momentum along x. Sa may mahitabuan, you have MA AX1 plus MB velocity V X1 is equal to MA VAX2 plus MB velocity V X2. Positive going to the right. MA is 1. May mo running ang VX1 mo is 598 plus MB is 2 times negative 0.7071. And then this is 1. So may mo running VAX 2 plus 2 velocity VX2. Okay, so ang answer ani or the equation for this one will be 1.184 is equal to VAX2 plus 2 velocity VX2. This is equation 1. So we need to find another equation. Makuha na siya using the coefficient of restitution, which is velocity Vx2 minus Vax2 all over velocity Ax1 minus velocity Vx1. Tama? Again, positive going to the right. So you have 0.75 minus Vax2 all over ang Vax1 2.598 Vax1 2.598 velocity V minus negative namin dyan, minus 0.7071 no? 0.7071. So the equation would be may muna learning velocity Vx2 minus velocity Ax2 is equal to 2.48. Okay, so this is your second equation. So, i-solve ng equation 1 and 2, you will get an answer of Vax2 equal to negative 1.26 and velocity Vx2 1.22. Okay? Pasabutan kani going to the right, kani 1.26 going to the left. Ang A. So, ang A ay balik dari. Okay? So, nakuha na nato ang X component. So, we will now get the component along Y. Okay? Now, for the component along Y, based on our previous discussion, there is no impulses along Y. So, therefore, MA VAY1 is just equal to MA VAY2. Cancel. So, VAY2 is just equal to VAY1, which is 1.5 meter per second. So, going upward. Okay, so in the same way, the same po sa B. Velocity Vy2 is just equal to velocity Vy1. Ilan niya siya? Negative 0.7071. So, pasagutan ni 0.7071 meter per second going downward. Okay? So, that's it. Okay, so just practice solving and medyo procedural naman sa